How you doing, guys? I'm Jeevan Singh, and I'm going to go through an A-level question, and this is C1, and it's on arithmetic series. So let me just explain the basics of arithmetic series. So all it is you've got a sequence, and it goes up by a certain number. So you just add a number to get to the next term. So let's just have a look at this example, and then we'll build our sequence on there. So we have each year for 40 years, Anne will pay money into a savings scheme. In the first year she pays £500. Her payments then increase by £50 each year, so that she pays £550 in the second year, £600 in the third year, and so on. Okay, so as I was saying before, all it is it's just a sequence, a common difference type sequence, and you would have come across this at GCSE level maths, but the only difference is now is you just have to work with some formulas on this particular sequence. So okay, as it says here, it says in the first year, or the first term would actually be £500. Okay, let's use this instead. Right. Okay, so the yes, the first term is £500, so that's £500, and you're adding £50 each time. So the next term in the sequence would be 550, and the next term would be £600. You just add £50 to that, and the next term would be 650, because you add 50 to £600, that gives you 650. And you just continue from there. So notice there is a general formula to find any term in the sequence. So you would have learnt this at GCSE level, but I believe the formula looks a little different. I mean, in my GCSE Maths in 4 weeks program, I actually go by the A-level formula. I don't see the reason why there is two different versions of the formula, but they're essentially the same thing. So this is what the formula is. So notice how we're adding 50 each time. So we add 50 here. And then what we do is we add, to get the third term, you actually add another 50, or yeah, we add a 50. So let me just put this here. Okay, but there is a general, there is a general formula behind this, because if we call our first term A, then our next term is going to be A plus D. So it's whatever that first term was, add the common difference. So you add D here. I mean, in this case you have 500 and then you add 50. Okay, the third term would be A. So it's that first term, but then add two of those common differences. So you add 2 lots of D. And just look at the actual example above. So 600, what we've done there is we started with the first term, and then we add a 50, and then add a 50. So we do the first term, add 2 lots of that common difference, whatever that common difference happens to be. I mean, here in this case, it's actually 50. Okay, so in general terms, you notice how it's always the first term, add the number, or 1 less than the term number, multiplied by D, because you have A is the first term, the second term is A plus D, okay, the third term is A plus 2D, so it's actually always 1 less than the term number. So that means the nth term would actually be A. So this is the nth term here, so the nth term. So whatever that term is, it's always 1 less than that term number. So it's A plus n minus 1, n minus 1, okay, there's some brackets there, n minus 1d. Okay, so that is the general formula there. Okay, so what the first part says find the amount that Anne will pay in the 40th year, right? So the 40th value is obviously the 40th term, so we just need to find the value, whatever the 40th value is going to be. I mean, it would be impractical to keep adding 50s here. You know, it would take you an awful long time to find what that 40th value is going to be. So that's why you use this formula. This formula allows you to find any term in the sequence. So we're looking for the 40th term because it's the 40th year, the payment in the 40th year. So it's the 40th term, or n is equal to 40. So 40th term, or n is equal to 40. And then you just simply go by this formula. So you go by the formula for the nth term. Okay, so we know that the first term is 500. N minus, so remember, as I was saying before, if you're looking for the 40th term, you do the first term add 39, and that's one less than the term number, multiplied by the common difference. So all you do is you do, the first term is of course 500, that always stays the same. So it's 500 plus 39 lots of 50. That's what it is. So yeah, the 40th term, remember, it's always one less than the term you're looking for. So it's the first term add 39, as we're looking for the 40th term. One less than that is 39. Lots of the common difference, which is 50. Okay, so I believe in C1 you don't have access to a calculator, so what you need to do is you have to actually work this out mentally or manually. So 500 stays as it is. Okay, if you're multiplying a number by 50, a quick way to do that is if you multiply this number by 100 first and then half it. So multiplying by 100 gives you 3,900. But remember, that is 100 lots, so for 50 lots you just half this number. Okay, and half that number you should be able to do mentally if you're an A-level student, and I believe that's just going to be 1,950, because if you double the 1,000 you get 2,000. Okay, if you double the 950, that gives you another 1,900. Okay, and then you'll have 3,900 altogether. So you just do 500 add 1,950, or 1,950, and adding those two together gives you 2,450. So that is how much she pays in the 40th year. So if you continued this sequence, so you continued it, you carried it on, the 40th term would actually be £2,450. So this is how much you'll pay into the savings scheme on the 40th year. So 2,450. So you just put your final answer on the dotted line there. Okay, so let's move on and let's have a look at the next part to this question. Okay, okay, this is all going to disappear now. So let's move on to the next part of the question. Okay, so it says find the total amount that Anne will pay in over the 40 years. Right, okay, so what that means is, what you're doing now is you're using the sum to the n terms. So all of those terms in the sequence, so let me just quickly put this on here. So just remember that the sequence was like this. You have 500, 550, 600, and so on. Okay, dot dot dot. Okay, we know the 40th term was 2,450. That was the 40th term. Okay, so this question here is you need to find the total amount over the 40 years. So what you're doing is you're actually adding all of these terms. So you're adding those first 40 terms. Okay, so what you use here, you use the formula for the sum to the n terms. Okay, there's two variations to this. So the first one is this one here, which I'll write just below this. So the first one, okay, usually denote it as s and n, the little n. And the first one is probably easier as well because it's slightly smaller, is n over 2. So the term number n over 2, and then a plus l. Okay, and a is always the same, but a is the first term, which is 500. Okay, the l is the last term in the sequence. So in this particular example, the last term, because we're summing the first 40 terms, the 40th term is the last one. So 2,450 would be the last term. Notice how they've used l as well. because it makes sense to call the last term L. Remember, this can vary. Remember, this A and L, remember, this can vary depending on the question. So it depends on, you know, how many terms you're summing. So here we're summing the first 40 terms. So we take the 40th term, which is 2,450, because that's the last term. Okay, there is a slight variation to this, and it actually comes with this, because remember, L itself, the last term, follows where it has to obey this rule here. I mean, to work out the last term, you'd have to do A plus n minus 1. Remember, as I was saying in the previous part, it's always whatever the term number is. So if you're doing the last term or the nth term, you can even call it the nth term, you always do 1 less than that and then multiply by d. Okay, so that is the formula for any term in the sequence. Okay, if I were to place it into there, what we do is we get the other variation. So we have Sn is equal to n over 2, so that stays the same. And then what we have is we have A, and then add all of this underlined. So you have A, add A, plus n minus 1, all multiplied by d. So all multiplied by d. And as you can see here, as we have A plus an A, so you can simplify that. And what that gives you is okay, n over 2 stays as it is. The only bit you can simplify here is the 2a, so you get 2a and then the rest of it. So n minus 1 multiplied by d. And this is the other variation to the sum to the n terms. So that's where it actually comes from. It actually comes from this formula here. So this is the first version, but when you sub in L is equal to A plus n minus 1d, remember that's the nth term, or the Lth term, you can even call it the Lth term. When you sub it in, you get the other version as well. So have a look in your textbook, they've given you this version too. Okay, but in this example, it makes sense to use the easier version because you know what these are. You know what the first term is and you know what the last term is. So you just simply plug those in. So S, as we're looking for the first 40 terms, is S40, and it's 40 here, is equal to 40 over 2, 40 over 2, and then in brackets, the first term is 500. And then you add the last term, which we found in the previous part to be 2,450. Okay, so let's just simplify all of this then. So 40 divided by 2 is obviously 20, multiplied by everything in the bracket. So let's just simplify this bit here as well. So the 500 add the 2,450. Okay, adding 500 to that will give you 2,950. So you just add 5, as you're adding on 500, you just add 5 to the hundredths column. Okay, and then you just need to multiply the 2. So the quickest way to do this would be to maybe multiply by 10 first and then double it. So multiplying by 10 is just simply 2,000, sorry, as you've got another 0, you have 29,000 now, 500. And then 20 lots, so let me just put this in brackets. Remember, this is times 10. This is 10 lots. Okay, so 20 lots is obviously double that. Okay, the quick way to double this, what I would do is I'd actually round this up to 30,000, double that, and then take away 1,000 from there. Because what we've done is when we round this up, we've added on 500. So when we double 30,000, we're going to be 1,000 too big. So what we'll have is if we double 30,000 and then take away 1,000, we're left with 59,000. So 59,000, and that is the sum to the sum of the first 40 terms. So 59,000. And don't forget to put your answer on the dotted line. So that is the sum of the first 40 terms. So just going back here, remember what that means is you're adding all of these terms. That's what you're doing. You're adding all of these here. So when you add all of these up, you'd actually get £59,000 total. So that's how much she actually saves or places in a saving scheme over those 40 years. Okay, if you have a look at part 2, so what I'll do is I'll try and squeeze this in at the bottom because I don't want to lose any of this, because this is actually going to tie in with the next bit. It says, over the same 40 years, Brain, I think that's spelled wrong, but I think that should be said Brian, will also pay money into the savings scheme. In the first year, he pays in £890, and his payments then increase by D each year. So Brian has a different sequence, or he follows a different sequence. So he actually starts off with 890. So I'll just do this. Okay, maybe it's best if I do scroll down. So let's just remove all of this. Don't worry, I will write this out again. Let's just quickly scroll down so we have some more space. Okay, so as I was saying before, remember the sum to the nth term is equal to n over 2. This is the shorter version, a plus l. Or the slightly longer version is Sn is equal to n over 2. And then in brackets 2a plus n minus 1. N minus 1 multiplied by d. Okay, so going back to Brian's sequence here, so his sequence looks something like this. So we don't know what this common difference is, but it will follow this rule. So you have 890 as the first term, and then you're adding d each time. So to get to the next term, you add d, and obviously we don't know what that next term is going to be because we don't know what d is, but I believe this is what we're going to find in this question to find d. So I think the key to this question is this bit here. You know when it says, given that Brian and Anne will pay in exactly the same amount over the 40 years, find the value of d. Okay, so we know that the sum to the first 40 terms in Brian's case as well, he saves the same amount of money over those 40 years as well. So what that means is in both cases, S40, so in Anne's case and Brian's case, S40 is equal to, okay, so this is the answer to the previous part. You notice how the parts follow through. So you're using the answers in the previous parts to guide you on the latter parts as well. So the answer to the previous question, I believe, was 59,000. Right, yeah, so that was 59,000. So S40, or the sum to the first 40 terms of Brian's sequence, is also going to be 59,000 as well. Okay, so what we need to do is we need to find d in this case. So obviously what would you have to use here? We would have to use this formula here. We'd have to use this formula because this has d in it. This value here, this formula here, this version doesn't contain d. So the only way to find something is that particular variable or letter has to be in the formula, because that is the unknown and you should have everything else. And if you look at this version here, which I've underlined, we do have everything else. I mean, obviously n is going to be 40 because it's the 40th term. A, we know for Brian is 890 because they've told us the first term. D is what we're trying to find, but we know that S40 is equal to 59,000. So what that means is n over 2. So using that second version, n over 2, 2a plus n minus 1 d is equal to 59,000 right. So remember, that is when n is equal to 40 because it's the first 40 terms. So it's just subbing everything in. So n is equal to 40, so 40 over 2, 40 over 2, and in brackets we have 2 times a, and a is actually 890 for Brian. So 2 times 890, so 2 times 890, and then plus n minus 1 multiplied by d is equal to 59,000. So all you need to do there is you just need to solve it for d, because that's what we're looking for. We're looking for that common difference. Because we know what the sum to the first 40 terms is, we know what the first term is, we can form an equation and then solve it for d. So just solving this for d, okay, what I'm going to do is I'm going to simplify everything. So what we have is, I'll continue it all here. So 40 divided by 2 is 20, and then open brackets, okay, 2 times 890. A quick way to do that is, if you round this up to 900, do 2 times 900 and then take away a 20, because when you do 2 times 900 it'll be 22 more, or 20 over, so you have to take away 20 at the end. So 900 times 2 is 1800, and then take away 20 from there would give you 1780. So that will be 890 doubled, and we have plus n minus 1 d, and that's all equal to 59,500. Okay, so just dividing through by 20, so because we have 20 lots of this whole bracket, means 20 times this whole bracket is equal to 59,000. Let's just get rid of that 20. So don't actually expand everything out here, because then you're just creating more work for yourself. So let's just get rid of that 20, because what we have here is we just got a number. This bracket here is just simply a number. Once we have all these letters N, D, this is just simply a number. So let's just divide by 20 on the other side, and what we're left with is, okay, also I forgot to put this bit here, because remember n minus 1 is going to equal to 39, because if n is 40, n minus 1 is 39. So we have okay, so 1780 on, we're just left with 1780 plus 39d, okay, and dividing by 20 on the right hand side, or dividing 59,000 by 20, what that is going to give you is, okay, so a quick way to do this, if you divide by 10 and then half it is the best way to do it. So divide by 10 and half it, that's the best way to do it. So dividing this by 10 gives you 5,900. So dividing by 10 gives you 5,900. Just take off a 0 at the end. But remember, that's when you divide by 10, that's well, 5,900 will go into it 10 times. So you need to half this, and that value there will go into it 20 times. So halving this value here would give you 2,950. Okay, and then let me just continue this on the left hand side. So this is what we're left with, so we can ignore this. 1780 plus 39d is equal to 2,950. Okay, so we're just solving an equation as normal. So what that means is 39, I'll just continue on this side, 39 is equal to 2,950 minus 1780. So okay, what I'm going to do is I'm going to use a column method here. So let me just quickly use a column. Well, if you were to use a column method, I won't do it here because it will use up a bit of space. So what I'm going to do is I'm going to cheat here. I'm just going to quickly punch in my calculator just to save a bit of time. But remember, you can't have access to a calculator, so remember to use the column method. So what it would look like is it looks something like this. So 2,950 minus 1,780. Okay, so 2,950 minus 1,780. So if you were to use the column method, what you're left with is you're just left with 1,170. Okay, so 39. Okay, remember this is 39d. So 39d. Remember, all I'm doing is I'm just solving that equation. When we plugged in all of those known values, n and a, we know the sum to the first 40 terms is 59,000. So all I'm doing is I'm just rearranging it and solving it for d. So 39d is equal to 1,170, and then you just need to divide through by 39. So 1,170 divided by 39. So what you'll do is you just need to, well, the way to do this is to go up in your 39s, or maybe go up in your 40s instead. Go up in your 39s, obviously 10 lots will be 390, 20 lots is going to be double that. So you just keep building it up until you get as close to 1170. But what you notice is when you work this out, D is going to equal to 30. It'll be 30 lots. I mean, I was saying before, if you were to go up in lots of 10, so 39 times 10 is 390. That's 10 lots. Double that will give you 20 lots. So doubling that will give you 780. And if you add another 390 from there, so it's not too difficult. Adding another 390, and that would actually give you 1170. So I mean, that's the best way to do it. You're just using chunking. You're dividing it, but you're just using chunking. Okay, and or what you could also do is you can also treat it as a fraction, so you can divide it by 3 top and bottom. That's one way of doing it, but what you'll get at the end is D is equal to 30. So this common difference here is equal to 30. So what Brian is doing is he's adding 30 each time. So every year he's increasing his savings or increasing his payments by £30. So the next one would be 920. The next one after that would be 950. And that's what it is. So remember to go over this question. Remember the key, if you really understand this, then it is quite straightforward to do. It's all about understanding it, understanding these sequences. Remember these sequences you came across GCSE level. The only difference is now is you've been taught these new formulas here, but they're not very difficult as long as you know exactly what they are, what they represent. It's just a case of substituting values in and rearranging it to find what the question is asking you to find.